Right now on Amplified, the Engineers Journal podcast, we're about to meet the top man at Varming Consulting Engineers, James Kavanagh.
An engineer is innately curious and has aspirations to better things, to change things, and to change things for the good. One of the challenges at the minute is sort of climate change and how that's tackled. Engineers have been designing sustainably for a long, long time. Sometimes maybe going into the profession they don't see that, but looking back on it, they actually appreciate how valuable, if you like, engineers are to society.
Hello, my name is Dusty Rhodes and you're welcome to Amplified, the Engineers Journal podcast, where we speak with leading members of our community about how engineers are delivering interesting and sustainable solutions for society. Joining us today is a man with huge experience as a fully qualified chartered engineer, registered consultant engineer, registered European engineer and a member of the Institute of Directors. Over the next half hour or so, he'll be sharing with us some of his 30 years experience at the forefront of award-winning design projects. CEO of Varming Consultant Engineers, James Kavanagh, you're very welcome.
Good morning, Dusty.
For those who don't know, can you tell us a little bit about Varming and the work that the firm concentrates on?
So Varming Consulting Engineers have been in existence. It's now our 76th year. In terms of engineering, we operate within the built, what's known as the built environment. So our appointments are based mainly around buildings, and within those, the engineering system supports buildings. So what we're talking about is mechanical engineering, electrical engineering, and passive engineering within buildings and to support buildings. So the heating, the lighting, the ventilation, the air conditioning. But more importantly, to support those systems, we're involved in the engineering of the skin, if you like, of the building, which controls the environment to a large extent within the buildings. Overall, I suppose we're responsible for the safe, comfortable and efficient design of buildings, modern buildings and their operation.
And how big is the firm?
At the moment, the firm is approximately 55 employees, full-time employees. We have offices in Dublin, but we also have offices in Cork and we have offices in Roscommon.
Now, you mentioned MEP, and a lot of people, when you say MEP, they go, oh yeah, mechanical engineering, plumbing. You didn't say plumbing.
No, MEP is a generic term, which a lot of people will understand as mechanical, electrical and plumbing. But the P in our case also means passive engineering. So in let's say the built environment in a building, you have the internal systems, which is the heating, the lighting, the ventilation. But in terms of passive systems, you have the skin of the building, which is actually controlling the heating. So things like insulation, things like facade design, energy efficient fabric, that type of thing. Basically anything that's not actively working is passive. So sunlight, natural ventilation, for example, would be quite a prominent system in terms of passive design. Used a lot in schools, for example. All schools, classrooms, general classrooms, are designed to operate passively through natural ventilation, through openable windows. So initially, the design would be passive first and then active.
So when you're coming to a project, you're looking, Grant, how can we get the skin right?
Yeah.
And then underneath the skin, then develop it from there. That ties in my head with climate change and sustainability, because you're trying to make the most of nature in order to make a more efficient building. Is that a fair comment?
Yeah, it's a fair comment, I suppose. One of the challenges at the minute is sort of climate change and how that's tackled. In terms of where we operate, let's say in the built environment, we're building buildings, if you like, at a rate faster than we ever have. I read some statistics somewhere that we're building the equivalent floor area of the state of New York every 34 days. Now that's a huge challenge, and within that, buildings themselves are responsible for 40% of the world's carbon emissions. 30% of that 40% is in relation to the operation of those buildings, and 10%, which makes up the 40% in round figures, is associated with what's called embodied carbon, which is the carbon associated with new buildings and building materials. So if you can get in and influence that element of life through our design, that's a key challenge, but it's also a key opportunity, if you like, to change things and change things for the good.
And what do you think are some of the smartest elements of design today?
I think the issue is to get to a situation where the engineering, let's say, community initially, like engineers are natural ambassadors for change. They're natural ambassadors for climate change. Engineers have been designing sustainably for a long, long time. I think the key issue is actually to get to a point where the engineering community actively combat, if you like, climate change, but they can't do that on their own. They can only do it in terms of their design. So we have a dedicated, and have had for a long time, a dedicated sustainable design team who works directly with architects, advising them in energy efficient design. In our own operations, we're accredited to ISO 14001, which is an environmental sustainability plan. So to answer your question, Dusty, it's not actually one actual thing. So it's not electric cars, it's not photovoltaics. In my mind, what it is it's actually an engineering community, first of all, coming together with sort of politicians and goodwill and making that transformation.
Why do you feel it's important for engineers to lead the way instead of client demand?
Well, what we're finding more and more is that the days of, let's say, first cost, best cost at any cost is starting to go. And in a lot of cases, what we are finding with our clients is that we're actually pushing open doors. All they actually really need to be aware of is to be made aware of the technology, and we're finding that a lot of them most of them are actually embracing it. There are let's say legal requirements, which all of our clients need to embrace in terms of climate change and their requirements. So we are pushing open doors. Things have changed. I'd say I would say that in comparison to when I initially came into the business, it's like chalk and cheese in terms of client awareness, let's say, of the issues.
Yeah, I was thinking about that because, the key words today in building design, and what I hear over and over, is sustainability and renewable energy and low carbon tech and smart energy management, all the things we're talking about. And this is all leaps ahead of what we had in the year 2000.
Yep.
What do you see coming down the line? What standards do you think may be common in 2050?
Well, where we are at the minute in terms of not so much standards coming down the line, but targets to be met by 2050, and indeed in some cases by 2030, is in terms of net zero or near zero energy buildings, and that's one of our keen interests. And at the moment, there are buildings which are achieving that standard, and we've been involved in some of them. One major issue in terms of commitment, and our commitment is our design service, sustainable design service that we provide both to in-house and external consultants as well. Change starts from within. So at the moment, we were the first dedicated consultancy in Ireland to be signatories to the World Green Building Council net zero carbon building commitment. We're signatories to the ACI pledge to net zero, and we support the Irish Green Building Council in building a net zero Ireland. What does that all mean? Well, what it actually means is that there's sort of 3 or 4 key strands to any of those commitments, which is commit. So as far as we're concerned, we've committed to only occupy buildings which are net zero in operation by 2030. So there's your 2030, but we're committing to it as Varming consulting engineers. As part of those commitments, we need to disclose and measure and disclose our own emissions. We need to act to develop a decarbonisation roadmap. Our head office at the moment is a multi-tenanted building, and we have representation there of what they call the green team, if you like, where all of the tenants and the landlord come together with a view to, upgrading the building from a practical point of view. Then we need to verify, and then we need to advocate. And where we're advocating to our clients, but in practice what we're doing is we're advocating through our consultancy and our consultancy advice. That's the way we're advocating. So change is happening, and it's in train. We just need to get there and keep the foot on the pedal, I think, Dusty.
A lot of what you're saying sounds great. But always the proof of the pudding is when you're actually getting out and doing. And you were involved in a really interesting project recently, which you won an award for, a Net Zero Award for Donegal Garda Station. Can you tell me about that? So
Donegal Garda Station, we've as Varming Consulting Engineers, we've won quite a lot of, let's say, industry awards over the years. The most recent one being Donegal Garda Station. Donegal Garda Station was built in the early 20th century, I suppose, around this time.
This time last century, yeah.
This time last century, yeah. When you think about it, that has been acting as a Garda station for, obviously, since then. So in terms of what we brought to the party, our in-house team carried out some dynamic simulation modelling, which validated the environmental sustainability of the project. So basically, desktop studies tested out our ideas before they were costed, before they were tendered, and they were proven to be correct.
How did you test them and be able to prove them to be correct?
Okay, so our in-house team, as I said, carry out dynamic simulation modelling. So we can actually model a building in terms of, as I talked to you about the skin and the energy performance. We can actually model that in real time. It's not steady state, what would be known as steady state conditions. It's dynamic, so it's moving. You can see this happening. And in terms of, let's say, the insulation, the facade design, we can model how that performs and have different, options. Design options, what will work, what will not work. And we're working very, very closely now on all of this, I must say. The key to this is actually working very, very closely with the architect and the client in particular, to explain the systems we're using and for them to understand and buy into those designs. So what we had, ultimately what it all came down to was both a refurbishment and an extension project at Donegal Garda Station. It consisted of the installation of air source heat pumps with enhanced insulation. The buildings, when they operate, naturally they leak, and if you can control that, you can actually control the level of heating that's required.
Can I ask a quick question then about that building? It's a 100-year-old building. Did you have to keep the original building, or were you able to just, kind of raise it to the ground and start afresh?
There was a small element of demolition, but that was purely as a function of the building itself. But primarily the building was retained and it was extended. So it was an extension and a refurbishment project. It was actually quite interesting and unusual, but apt, as we said, in as far as, let's say, a building which has been refurbished. You asked what I thought was going to change, particularly over the next, 10, 20 years or whatever. I think what we're going to see, and we know it's going to happen, is let's say the refurbishment, the repurposing of buildings, as opposed to the demolition and new builds. If you remember, we talked about the embodied carbon and 10% of that 40% being associated with new projects. I think we really need to ask ourselves: do we really need to demolish what we're demolishing, or can we repurpose it?
Well, what is the challenge then of taking an existing building, and in Ireland we've got a lot of very, very old existing buildings, and then bringing them up to a modern standard?
It depends, Dusty. It depends a lot on the type of building we're talking about. Like if you take an office building, for example. Okay, the focus of the building is actually from an occupant's point of view, insofar as a safe, comfortable environment for office work. Okay, if you on the other hand look at any industrial building or process or whatever, the focus of the systems are actually either on the safe or operational aspects of the product, let's say, or the process. So if you took, for example, operating theatres, the key issue there is actually safe and sterile environment for operating. Now, it would not necessarily be practical, if you like, to repurpose every building for an operating theatre. Some things have to be built from scratch. If you took a biocontainment lab, for example, it would not necessarily be practical in all instances to repurpose another building. If you took a residential building and an office building, there are synergies there between both of them. You with me? So it's repurpose, if you like, where practical and safe.
James, let's dig into hospital systems kind of a little bit more, because you're saying like operating theatres, obviously they have to be safe and sterile, and you really need to make them modern. But when it comes to hospital systems, I mean, what are the kind of challenges that are unique to medical facilities?
Healthcare facilities are basically broken into acute and non-acute. Acute hospital, for example, would have an operating theatre, radiology, all of those, let's say, specialist departments. A non-acute, basically ward block element type of thing. So they're not immediate, if you like, more long-term treatment. One thing that's really important in a hospital environment, and indeed a lot of industrial environments, is the ability to keep the system running. There is a situation, for example, where they just cannot accommodate shutdown. So, for example, in operating theatres normally come as a suite of operating theatres. You may have 4, you may have 6, you might have whatever. You very rarely have one operating suite. And systems are broken are broken down when they're designed, so as one system can't sit down, let's say, for maintenance or whatever while running. So there's the whole standby and what's actually called resilience in terms of sizing plant, sizing electrical plant, sizing mechanical plant. HVAC is heating, ventilation and air conditioning. And then there's the electrical systems such as generator, life safety systems and everything which supports those and supports the system. So one of the major challenges is the need, if you like, to keep things going. The need to anticipate what next. The need to ensure that the systems are cleanable and we do a lot of interaction, let's say, with infection control people within hospitals. An operating theatre, people will think of an operating theatre, but it's actually an operating suite. And there's 2 or 3 different sort of standard, let's say, layout suites. But a general suite, let's say, would consist of the operating room itself, but also the layout prep room, the scrub room, the anaesthetic room, and then let's say the dirty utility, if that was in the design. So there's a suite. There's a suite of rooms. And one of the key challenges there from a ventilation point of view is that the air systems, they actually control the flow, let's say, of air from clean areas to less clean areas. And that may sound very simplistic, but it's actually quite challenging sometimes to actually get right. So that's in terms of, let's say, infection and infection control. And that's fundamental in terms of the design of operating theatres. It's actually very similar to the design of clean rooms or biocontainment suites, where it's slightly the other way around. So one of the key challenges in terms of HVA systems across, a number of types of systems and facilities is actually the flow and the pressure profiling and achieving between areas. So that's challenging.
Is it the challenge to clean the air, or is it the challenge of routing the air to get it from A to B?
It's actually both. As I said to you, there's a small number of standard layouts for, let's say, operating theatres. One type of operating theatre is called the UCV, which is ultra clean ventilation system. That's used primarily for bone surgery, which seems to be quite susceptible to infections. You open up your knee and it's, so orthopedic surgery. So the challenge there, and then the challenge likewise is actually, number one, as you say, cleaning the air, which is simple enough, right? There's enough, let's say, systems, technology, filtration systems out there to clean it. But the real challenge is when it's clean, okay, is to make sure that it's actually flowing where it should be, so that it doesn't interfere either with product, let's say, or personnel contamination. I'm talking about product contamination, for example, very similar, although much higher grades of filtration if you're talking about, let's say, chip manufacture, semiconductor manufacture.
And where do you find the solutions? Is the solution in the piping? Is the solution in the filters that you use?
The technology is out there, but the actual solution is in the engineer who's designing the system. That's where the solution is. And the solution is in relation to the interaction. For example, if we're talking about, theatre suites is the close sort of interaction and collaboration, for example, for the architect. Okay, because you can have systems, let's say, which, there's very small air differentials which make a difference, and maybe a sort of a loose fitting door or whatever, may have an effect, will have an effect on the building, and it's everybody in the design team being aware, let's say, of the design parameters and what's required. It's challenging. What I would say, Dusty, is it's challenging. But for people in the business, it's more unique than challenging. You would look back on a number of projects where they would be sort of unique. They would give you sort of being in the engineering profession would give you sort of an insight into things you wouldn't, let's say, normally see. As I said, operating theatres, industrial ventilation, clean room design. It's a little bit of a sort of it gives you an opportunity, that little sort of peek behind the curtain. How does it actually work? I think that, as I said to you, whatever about engineers being sort of natural ambassadors for change, innately they're curious people. They want to know how things work, and a career in engineering will give them the opportunity to see that, but it'll also give them an opportunity to be involved in the design of either the systems themselves or indeed the systems that support them, which is what I've found particularly beneficial, if you like, from the career in engineering, particularly building engineering.
Let's talk a little bit more about keeping that spark in your brain and the curiosity going and always looking for new and interesting solutions to problems. Varming is known for a very strong spirit of creativity and innovation, and you're the CEO at the company. How do you keep that spirit alive with the staff?
I qualified from what was Bolton Street, now at the College of Technology, and what is now TU Dublin. I qualified as what was known as a building services engineer. I've maintained links with the college, particularly with the stream of building engineers coming from that course. The spark is naturally there when they go in, to answer your question. All right. So one of the sources is actually to get people who are, let's say, adaptable, ambitious and aspirational. And we found people, generally engineers, that's what they are. They are adaptable, they're ambitious and they're aspirational. They want to change things. And we found that course in particular a particularly good source. Now, some people may say, well, you would say that, James, because you're from that course, but it is actually the truth. When we get them, when they come into our organisation, they have the support of our QHSE system, which is our Quality, Health, Safety and Environmental system. And there we have a mentoring programme. And Engineers Ireland, we have for many years been part of their accredited CPD programme. And we know, and I know directly from talking to our younger staff, that is a huge support for them.
As you say, getting people into the company, and if they're natural and they're curious and they're great engineers, but finding those people in the first place seems to be getting harder and harder. Do you feel that the system is succeeding in getting new engineers into the business?
It depends on which system, I suppose, Dusty, we're talking about.
I think the education system from, secondary school through university and technical college.
Yeah, I think from what I found personally with my experience of that is in terms of drivers and what actually influences people to go into any profession. One of the curious things we may think it's changed, but it hasn't changed, is one of the main drivers for people when they're choosing a career or a profession is their parents and is their peers. And that's actually been sort of proven scientific fact, through some of the work that TU Dublin have done. That's a fact. They're one of the key drivers, but also what's one of the key drivers is the when that happens. That happens effectively in first level in primary school. A lot of people make up their mind in primary level what they're actually going to do for the rest of their career initially, anyway.
How then does engineering sell itself to primary school students, or does it? I'm thinking, when I was a kid, right, I wanted to be a farmer, I wanted to be a bus driver, I wanted to be a spaceman. There were all these kind of little things that I could see around, and they all look. Engineering, I don't walk past a building going, I'd love to be able to design a building like that one day.
Yeah.
How do we get these kids engaged?
We in Varming's, we have actually gone into, as you said, we maintain our links with the colleges and with second level schools as well. But a big help of that is that we've also been involved in the Engineers Ireland STEPS programme. The Engineers Ireland STEPS programme is a programme where they actually target what I would call first level, which is primary level, and secondary level students. And that's to open their eyes in relation to engineering and the different facets of engineering. And I think there's a requirement, let's say, on the particular industry to then go and highlight, if you like, the aspects of that particular industry. So what I'm saying is where I'm coming from, I'm highlighting the aspects in terms of what's called building engineering, because I have particular interest in that. But the STEPS programme, in terms of getting people interested in engineering and the STEM subjects, is really a good programme, and a support really for the industry as well as the students.
Tell me, just to kind of wrap up our chat today, what challenges are you facing yourself over the next 2-3 years?
The challenges that we're going to face over the next 2 or 3 years are no real different to the challenges we would have faced over the last 2 or 3 years. It's just that some of them will come to the fore or step back depending on where we are in an economic, let's say, cycle. So one of the big ones, and we sort of hit on it as well, is the general sort of skill shortage in the profession. But that's not only Ireland. That's throughout the world, and we know that. For every sort of challenge, I suppose, there's opportunity. So the opportunities in terms of the skills shortages, insofar as that it tends to create diversity within the workforce, which is needed, and as well as that, it can go to address, let's say, the gender balance that needs to be addressed, particularly within the building industry. The inflationary pressure brought upon by the global pandemic, but also now the war in Ukraine. We don't know when that's going to finish, but that's having a huge knock-on effect in terms of building confidence. So that's a challenge, an immediate challenge. But again, there's an opportunity, as we said, in relation to lean design that can address that, go some way to address that. There's opportunities there in terms of the adoption of modern methods of construction and modern simulation techniques such as BIM. So there's, for every sort of challenge, there are opportunities. There's a constant need, if you like, to keep up with technology, but that's also, how you say, an opportunity for engineers who want to progress their career through increased learning. You know what I mean? A lot of engineers, they qualify as engineers. Some actually, diverse into other professions. So in terms of sort of challenges, there's always sort of opportunities that's brought to the table, if you look at it that way. On the more, let's say, local level in relation to Ireland, one of the big challenges is actually delivering, I suppose, on the National Development Plan. In as far as 2021, I think, 21 to 2030, you were talking about 2030 earlier on. There's a huge investment there planned, 165 billion in relation to public funding. And engineers in general will be required to deliver on that. So that's a challenge, is actually delivering on the National Development Plan on a countrywide level, as well as bigger issues on the global field.
James Kavanagh, CEO of Varming Consulting Engineers, thank you very much.
Thank you, Dusty. Good to talk.
If you would like to find out more about what we spoke about on the podcast today, you'll find show notes and link details in the description area of your podcast player right now. Our Amplified podcast was produced by dustpod.io for Engineers Journal. You'll find advanced episodes at our website, engineersireland.ie, or just press the follow button on your podcast player right now to get our next episode automatically on Apple, Spotify, or whatever podcast player you're using. Until next time, from myself, Dusty Rhodes, thank you for listening.